Okay, guys, in this video, we are going to find the equation of a tangent plane, but we are going to actually use it to find an approximate value of the original function at the point that is close to a certain point that they will give you, okay? So let's go over the steps. The first thing we have to do is find the partial derivative, okay? So we're going to take the partial derivative with respect to x of e to the power 9 minus 2x plus 13y. Now here we have to use the chain rule. So e to the something, how do we take the derivative of e to the something? Well, e to the something is the same e to the something, right? Because e to the x is e to the x. So that will stay the same, whatever same something. But then you have to multiply by the derivative of that something with respect to x. So think of all terms that do not have an x as becoming 0. So 9 doesn't have x, it'll drop out. It's like a constant, it's 0. 13y is also doesn't have x, so that's going to drop out. So the only term that has x is negative 2x, and derivative of that is negative 2. Okay, so that's partial with respect to x. Let me just type that here. Okay, now similarly, I'm not going to explain why because it's the same thing. You're going to get the partial with respect to y. So then to find the equation of a tangent plane, you need to figure out, okay, at which point you are trying to do this. So it says 11, 1. So this is your x0 equals 11, y0 equals 1. So now you want to plug those two, x0, y0, into the original function, but also into the partials. Okay, so let's see if we can do that. And actually, in this case, it's probably going to be a nice value. Oh, okay. So to do that, you just have to put it in parentheses because it keeps switching. Okay, down. So we want to plug 11, 1 first. So that's the original function, okay? Then we want to plug the partials are different from the original function in that they have these constant multiple things. And so we're just going to multiply them, right? So the partial fx partial will just be fx at 11, 1 should just be negative 2, right? So if I put fx here as negative 2 multiplied by whatever that is, that should just give me negative 2. And then fy will be the same thing, but like 13 multiplied by that e function, right? So then fy at 11, 1 will be 13. Okay, so how do we find the equation of the tangent plane? So general formula looks like this. We have to plug the point into the original function, right? So it's going to be like f of 11, 1. Then you're going to do plus fx at 11, 1 multiplied by x minus the x coordinate of the point, which is 11, plus fy at 11, 1 multiplied y minus the y coordinate, which is 1. Okay, so that basically what's going to happen here, but let's substitute. So the original function was 1 plus fx was negative 2, so that's going to be actually negative 2, and fy was 13. Okay, so that's your equation. This is like z equal that, but we do want to simplify this. So let's just distribute that stuff. So I got negative 2x plus 13y. Don't forget about Desmos complaining. I'm just typing this stuff. Okay, so that would be plus 10. Okay, so that should be my equation. Okay, so hopefully that looks like that's correct. By the way, we can check that if we were to put the txy equals negative 2x plus 13y plus 10, if we plug in our point, it should give us the same thing, right, as the original function, and it gave us 1. So at least that's like a double check to make sure that this looks like it's correct. Okay, so then what we want is we want an approximate value of the original function at not at 11.1, but something very close to 11.1. So 10.9 close to 11 and 1.1 is close to 1, right? So why would you want to do that? Well, imagine, which doesn't quite make sense because nowadays you got, you can plug in anything you want into the original function. You can plug in 10.9, 1.1, and technology is going to give you the answer. Sure, but imagine that you don't have this technology and all you have is a simple calculator that can add and subtract, multiply, divide, and that's basically it. So if that's all you had, then you would plug in your 10.9 and 1.1 into the tangent plane and it'll give you an approximation. Okay, so if I were to plug in this value 10.9 and then 1.1, it gives me 2.5. Okay, so that's an approximate value that I could say, okay, if I didn't have this fancy technology, then that would be the best I can do. Which, by the way, since we do have it, we can just check it, which we're not supposed to do because we're not supposed to use the original function. So when it asks you to use the tangent plane to do the approximation, please use the tangent plane. Please use that. You don't use the original equation. I just want to, for the heck of it, just plug in and see, is it close to what it is, and it is not even close. So this approximation really sucks, and I am not really sure why. I do not like it. So probably the problem is that with the e function is that if you go a little bit away from the value, it's not gonna, because the e function is really fast growing. So if you were actually closer, like something like this, you would, your approximation probably wouldn't suck this, but like this really sucks. Yeah, see, like if you were very close, maybe I should change the code to this. So if you're very close, then the approximation was not bad, but if you were like off by 0.1, useless.